Long short-term memory. Description. Long short-term memory LSTM networks are a type of recurrent neural network RNN designed to capture long-term dependencies and mitigate the vanishing gradient problem. They are particularly effective for tasks involving long sequences and time series data. Key components. Cell state. Description. The cell state is a memory element that runs through the entire LSTM network, maintaining information over time. Hidden state. Description. The hidden state is the output of the LSTM unit for a given time step. Gates. Description. Gates are used to control the flow of information into and out of the cell state. Types. Forget gate. Description. Decides what information to discard from the cell state. Activation function. Sigmoid. Input gate. Description. Decides what new information to store in the cell state. Activation function. Sigmoid. Cell gate. Description. Creates new candidate values to be added to the cell state. Activation function. Tanh. Output gate. Description. Decides what part of the cell state to output. Activation function. Sigmoid. Working. Initialization. Description. Initialize the weights and biases of the LSTM network, as well as the initial cell and hidden states. Forward propagation. Description. Process each element in the input sequence one at a time. Steps. Forget gate. Description. Calculate the forget gate output to decide what information to discard from the cell state. Input gate. Description. Calculate the input gate output to decide what new information to add to the cell state. Cell state update. Description. Update the cell state by combining the forget gate and input gate outputs with the new candidate values. Output gate. Description. Calculate the output gate to decide the final hidden state for the current time step. Hidden state update. Description. Update the hidden state using the output gate and the updated cell state. Loss calculation. Description. Compute the loss for the entire sequence by comparing the predicted outputs with the true labels. Backward propagation through time BPTT. Description. Compute gradients of the loss with respect to the model's parameters by unrolling the network through time and applying backpropagation. Parameter update. Description. Update the model's parameters using an optimization algorithm like SGD or ADAM. Applications. Language modeling. Description. Predict the next word or character in a sequence. Used in text generation and autocompletion. Machine translation. Description. Translate sentences from one language to another. Speech recognition. Description. Converts spoken language into written text. Time series forecasting. Description. Predict future values in a time series based on past observations. Sentiment analysis. Description. Analyze the sentiment of text data, such as determining the polarity of a review. Advantages. Long-term dependencies. Description. Effectively capture dependencies that span many time steps. Mitigates vanishing gradient problem. Description. Uses gates to control the flow of gradients, preventing them from becoming too small. Challenges. Computationally intensive. Description. Require significant computational resources, especially for long sequences. Complexity. Description. More complex architecture compared to vanilla RNNs, leading to increased training time and difficulty in tuning hyperparameters. Recent advances. Bidirectional LSTM. Description. Process the input sequence in both forward and backward directions to capture past and future. Context. Attention mechanisms. Description. Allow the model to focus on relevant parts of the input sequence. improving performance on tasks like translation and summarization. Combining with CNNs. Description. Use CNNs to extract features from data, e.g., images, and LSTMs to model sequential dependencies, e.g., video sequences.